Welcome to Maths Gym. In this lesson, we are going to learn about complex number and how to solve some problems related to those. It is from miscellaneous exercise, question number 4. This miscellaneous exercise is on chapter number 4 from NCERT textbook, class 11th. If x plus iy is equal to square root of a minus ib upon c minus id, prove that x square plus y square whole square is equal to a square plus b square upon c square plus d square. While attempting this question, you should know that there are some fundamentals on complex number, that a complex number is written as z and they can be represented as a plus ib, and conjugate of z is z bar, which is equal to a minus ib, and so on and so forth. The rest of other mechanisms remain same as what you have learned in algebra in your previous classes. So we are given that x plus iy is equal to square root of a minus ib upon c minus id. Squaring both the sides, what do we get? We get x plus iy whole square is equal to square root of a minus ib upon c minus id whole square. And when we do an expansion on the left hand side, what we get is, if you see how do we expand this left hand side, it's basically on the rule which you have learned since class 8th. It is a plus b whole square is equal to a square plus b square plus 2ab. Well, some may remember it as a square plus 2ab plus b square is one and same, because commutativity in addition is allowed. So left hand side becomes x square plus iy whole square plus 2 times x into iy, and on the right hand side, in the next step, you'll find that the square root is gone, as because there is a squaring of the entire right hand side. So left hand side becomes x square plus I square y square plus 2 I times 2xy plus a minus ib upon c minus id, and you see that x square plus I square becomes minus 1, because in complex number you know that I is equal to root of minus 1, so I square is equal to minus 1. So x square minus y square plus I times 2xy is equal to a minus ib upon c minus id. Now, in the next step, we are going to work on the right hand side and multiply the numerator and denominator of right hand side by the conjugate of denominator. So we get on LHS, there's no change. X square minus y square is equal to I times I to 2xy is equal to a minus ib into c plus id upon c minus id into c plus id, and we have a motivation to do this, but multiplication by conjugate of the denominator. The idea is that the denominator we will be removing the imaginary part. How do we do that? It's as a part of the algebraic expressions. Left hand side is x square minus y square plus I times 2xy is equal to a minus ib into c plus id, and denominator has become c square minus id square. If you remember, a plus b into a minus b is a square minus b square, the same concept we have applied on the denominator of the right hand side. So c square minus id whole square, and what it eventually becomes, x square plus y square plus I times 2xy. Numerator, let's expand as the normal bracket expansion, a times c plus id minus ib times c plus id, and the denominator has become c square minus I square d square, and you know that I square is minus 1, so minus of minus 1 will become plus 1 in the next step. So the denominator has now become c square plus d square. Numerator, when we open up the bracket, it is ac plus iad minus ibc minus I square bd. And again, in the next step, you will see that this minus I square can be written as plus 1, because minus of minus 1 will become plus 1. So x square minus y square plus I times 2xy is equal to ac plus iad minus ybc plus bd upon c square plus d square. And this again, we have applied a formula minus of I square, which is basically minus of minus 1. Left hand side is continuing to the same. On the right hand side, what do? Is we collect the real and imaginary part together. So AC and BD we are collecting. So AC plus BD plus I times AD minus BC divided by C square plus D square. And let's segregate the real and imaginary part on the right hand side. What we get is AC plus BD upon C square plus D square plus I times AD minus BC upon C square plus D square. The idea behind this is that now we will compare the real and imaginary part on the left and right hand side. So what do we get? if you compare real and imaginary part from left hand side to right hand side, x square minus y square will be equal to ac plus bd upon c square plus d square, and 2xy will be equal to ad minus bc upon c square plus d square. And we know that x square plus y square whole square, pay attention, x square plus y square whole square can be written as x square minus y square whole square plus 4x square y square. Take a look at what the concept we have used. It is basically a plus b whole square can be written as a minus b whole square plus 4ab. I repeat, a plus b whole square is equal to a minus b whole square plus 4ab. Do an expansion and just get a confidence for yourself, but you need to memorize this formula as well. In this particular step and case, what has happened, a is equal to x square and b is equal to y square. So we can write x square plus y square whole square is equal to x square minus y square whole square plus 4x square y square. So this implies x square plus y square whole square is equal to x square minus y square whole square plus 2xy whole square. Okay. That is the purpose why we have written this 2xy whole square, because now we know you have a value x square minus y square, which we are going to substitute within first bracket, this bracket on the right hand side, and for 2xy you are going to substitute ad minus bc upon c square plus d square. So while doing the substitution, we arrive at x square plus y square whole square is equal to ac plus bd upon c square plus d square whole square plus ad minus bc upon c square plus d square whole square. And when we do the expansion, what do we get? So on the right hand side, what we get is, let's combine, because we can see that the denominator is same. So it's going to be ac plus bd whole square plus ad minus bc whole square. And that's how right hand side is. When we expand, it becomes a square c square plus b square d square plus 2abcd plus a square d square plus b square c square minus 2abcd. And you can see that plus 2abcd and minus 2abcd can be cancelled out. What we are left with is x square plus y square whole square is equal to a square c square plus a square d square plus b square d square plus b square c square upon c square plus d square whole square. And basically, because in the denominator we have c square plus d squares, we'll try to collect apply the distributive property in the numerator of the RHS to see that we get the same. We are basically collecting a square plus c square, a square common, and we are getting c square plus d square. In the second two expressions, we take b square common, we get c square plus d square, which basically means c square plus d square times a square plus b square is equal to upon c square plus d square whole square. And denominator can be written as c square plus d square into c square plus d square. And you can see that you can cancel out c square plus d square, and what are you left with? X square plus y square whole square is equal to a square plus b square upon c square plus d square. And that's what you had to prove. Thank you for watching the video.